Hello. This video will show systems and benefits of automating method development and purification in countercurrent chromatography using AutoLab, a coordinated combination of AutoMDS and AutoPREP, with examples from a big-pharma purification lab installation. My name is Gary Yannick. I am with PDR-Separations. My email is gwyannik@pdr-separations.com. Introduction. Objective is to automate CCC method development and purification to support short-run, fast-paced, unattended operation using AutoLab, a coordinated combination of AutoMDS and AutoPREP. Traditional CCC method development, such as shake flask, are labor-intensive and much different from HPLC method screening. AutoMDS includes an eluent mixer to create eluents on demand from 10 or 20 bottles. AutoMDS CCC methods can contain multiple unique cycles, for example, fill, equilibrate, load, and extrude. Each cycle and each method can be unique and/or can be repeated multiple times. AutoMDS CCC method screening sequences step through solvent system options, the same as HPLC method screening sequences step through eluent and column options. AutoPREP is fully coordinated with AutoMDS and has the same user interface. Features of CCC AutoLab: automated control of CCCs, pumps, detectors, chillers, etc. On-demand eluent mixing from 10 or 20 bottles. Injector and collector in one compact module. Syringe pump injector has 8 programmable inlet ports. It can inject sandwiches of sample in solvent, sample dissolved in stationary phase, and sample dissolved in mobile phase to minimize equilibration upset. Automatic selection valves to change between normal and reverse phase directions, and analytical versus preparative loading coils in the DE spectrum. Collect using various detectors, UV, pH, polarimeter, etc. The same user interface for all techniques, CCC, HPLC, etc. So why use CCC? CCC can process dirty cycles because there is no column packing and the whole system is easy to clean. Here is an example of an empty feedstock bottle from a real job, and here is the dried product flask from the same job. Can you imagine doing this with an HPLC column? Here is a photo of the PDR low-pressure gradient mixer, available with 10 or 20 bottle capabilities, provides on-demand mixing, isocratic or gradient, and independent control. There's a computer inside to run the method. Our flexible injector collector has 8 inlet ports to support flexible injection schemes, rinsing, etc. This version can collect on 9 peaks. Larger sizes are available, and AutoLab can also control injection pumps for very large injections. Here's a photo of AutoLab installed on a dynamic extraction spectrum that has both analytical and semi-preparative windings, 24 versus 267 milliliters. Here are the degassers. Here is the mixer. Here are the dual pumps in order to achieve adequate flow. To do the semi-prep version of CCC in this system, we needed to parallel two pumps. All of the eluent goes through both of the pumps, but it doubles the flow capability. Here is the injector collector. Here is the valve box that changes between normal and reverse phase flows, and the analytical versus preparative windings in the CCC. Here's the actual CCC itself, and here's the Agilent UV DAD detector. DE spectrum comparison. Before, there was 4-channel solvent mixing. After, there's 20-channel solvent mixing. Before, injections were slow and limited to 100 microliters. Now, the injections are faster, have 8 programmable inlet ports, and no limit on the volume. The syringe pump will keep pumping until we tell it to stop. Before, the manual switching valves needed to be moved to change between analytical or preparative loops and normal or reverse direction flow. Afterwards, the valves were automatic and selected these without human intervention. All of the settings were contained in the methods. Before, the software was Agilent ChemStation, which is good software, but it didn't provide control of the CCC or the chiller, so was not appropriate for overnight operations, and also it has limited collection settings as compared to AutoLab. The software now is much more flexible, controls the complete system, supports overnight operation, can collect on UV, pH, polarimeter, etc. Very flexible collection schemes. Okay, the DE spectrum plumbing. First look at the plumbing with the standard HPLC column you see in the red circle on the right. We modified the system so that it looks like a single column from the left-hand side of the plumbing diagram, but on the right-hand side, there are 2 valves and the analytical and preparative windings on the Spectrum CCC that are switched in the method in order to create the column. So in essence, we're creating a column brand new for every injection. Any column can be created as long as the possibility of mixing the solvents in the mixer exists. Here is an AutoPREP on JCT Optichrome. This is approximately 1 liter larger system. Here are the eluent test bottles used to confirm that the method is exactly correct. And then we changed the solvent switches on the left-hand side in order to connect to the pressurized solvent containers that were, of course, mixed as per the optimization just confirmed. Here is the injector collector. Here's a photo of the same system inside the hood with pressure vessels. On the left, you see the eluent pressure vessels. On the right, you see the collection vessels. In this particular system, the workflow is approximately as follows. Prepare the sample in both mobile and stationary phases and connect to the appropriate inlet ports of the injector. Select the appropriate screening sequence and run automatically. After the sequence, the data processing tool filters chromatograms based on the chromatographic results and your settings. You can select the number of peaks, the ratio of peak areas, retention times, minimum peak values, etc. You select the best method from the screening results and optimize using single keyboard control of all parameters. Switch to semi-prep mode if using a spectrum, or move to a larger purification system like the 1-liter JCT. AutoLab is hardware independent, has the same user interface regardless of hardware or scale, so the methods and sequences transfer directly. Optimize at prep scale, set up and verify collection settings, start the run, and collect automatically. Here is a typical CCC chromatogram. Notice the chromatograms mark the movement of the collection valves to show you when collection started, and again when collection stopped. This is recorded in the chromatogram and can be used retroactively to see if a problem existed and why. Conclusions. CCC method development and purification are now routine. Systems run unattended overnight and weekends. CCC operation is now similar to HPLC operation and used comfortably by non-CCC experts. Productivity increased by at least 5 times, and staff has more time for other tasks, thanks to the automation and simplification of AutoLab. AutoLab is generic and can be applied to any CCC CPC. Users now scout for new solvent families automatically to expand the applicability of CCC and/or CPC. When you're ready to expand your CCC or CPC operations, contact me at gwanik@PDR-Separations.com. Thank you.